DNA is, of course, a double helix. DNA has been described as a spiral staircase where the steps of the staircase are the base pairs. There are two steps. One of them is the GC, the guanine-cytosine stair step, and the other one is the adenine-thymine stair steps. The base adenine and thymine only go together one way. The base guanine and cytosine only go together one way. So there's really only two stair steps. But a given stair step has four possible orientations. It can be like this, or like this, or like this. So there's four possible orientations. I want to go straight to this model to demonstrate how this might work. The model consists of these paper models of the base pairs. The models are correct enough for our purposes here in that they have no symmetry. They have a front and a back. There's kind of an aspect that they have the black stripe and not the black stripe. So there's a black stripe up, black stripe down. They're not symmetrical on the top or on the bottom, and they're not symmetrical on the right or on the left. They're not at all symmetrical. So this is stair step guanine cytosine, and then the other stair step is similar. It's not symmetrical. It has a top and a bottom, which is to say it has a striped side and a non-striped side, or a black striped side and a non-black striped side. So let's just move forward with this. We have the codon is going to be on this side. The anticodon is going to be on this side. This is just a thing you can kind of hold it and demonstrate it. So let's start with adenine. Adenine, let's call it black stripe down for adenine. Okay, so adenine is black stripe down. So we have adenine black stripe down. Let's put the codon over here, the anticodon over here. So adenine is the codon. So we want thymine to be the codon. There's two possibilities. One of them is that the thymine is turned around this way. Another one is that the thymine is turned around this way. Well, it turns out that the second possibility is the correct one. So for thymine, the thymine is turned over from black stripe down. We want black stripe up. So the thymine, black stripe up, goes against the adenine. So the adenine is the codon. Now the thymine is the codon. And, okay, let's go to cytosine. Cytosine, let's go ahead and put the cytosine on, black stripe up. So if cytosine is the codon, we want guanine as the codon. We have two possibilities. We can turn the guanine over this way, or we can turn the guanine around this way to put the guanine on the codon side. So there's two possibilities. It turns out that the correct one is to put the guanine with the black stripe down. So from the cytosine to the guanine, we have the black stripe down. Okay, so guanine, okay, adenine is black stripe down. Okay, so what do we have here? Well, one of the things that comes out of this is that the same edge is always pointing the same direction. So in DNA, we have the major groove and the minor groove. The major groove always sees the same edge. Like, for example, for the guanine-cytosine base pair, the edge it's the same edge. It's either one way or the other. And since the base isn't symmetrical, it makes a difference on the edge. And then, of course, the other edge is seen in the minor groove, which is not at all the same. The major groove and the minor groove are very different, and they have show very different physical characteristics to the proteins that are looking for.